Okay, so I'm going to break from my typical habit, and instead of going through the code first, I'm actually going to go ahead and cover the finished form itself first. Okay, since this is the season of voting, I decided to make a little applet to generate a random list of 40 people and then have them go through the process of voting. So first I click the generate people list. That's done. It's actually an array, but that's neither here nor there. Then I'm going to go ahead and click the get more voters. This will allow it to change the people who would not normally be able to vote, illegals, dead, uh, people who are felons in certain states, and it would allow them to register to vote. Started with zeros, tried to get as many more voters as we could, but we only got 0 more voters. Not looking good. And then we go ahead and click let's vote. The Democrats won. So as we can see, it was a complete and utter landslide for the Democrats. The Republican Party claims the Democrats cheated to win the election. The Republicans have evidence that 0 of the voters weren't legally allowed to vote. So even though they claim they cheated, it apparently didn't work out in their favor this go out. So then I click OK, and it resets it. So let's run through it again. To get more voters. We started with 40. We tried to get as many more voters as we could, but we only got 0 more voters. And then we click let's vote. Republicans won. And there it goes. So as you can see, you can actually choose from the various lists of different names, but the system runs so fast that since it's using the system clock to choose from the list of names, it really doesn't have much time to choose because it's going through the loop so fast that the clock isn't updating terribly much. But this was not required by the class, but I decided to do it anyways just to generate the names and deal with that. But I used enumerators in order to hold names. I used enumerators in order to hold the voter status. And then my big Uber baseline class that gets inherited by not less than 3 other classes is the person class. And the person class has its public gets and sets. It's unique in this because the sets are generated within the class itself. So when the class is first constructed, as you can see down here, it will actually call its own private set. Theoretically, if I change these to protected when it was inherited by another class, I could actually have it do protected sets within the inheritor class. Or I can have methods and functions within this call it in order to reset it. So we have public int get voter status, return int this person's status, which actually converts the enumeration for the person's voter status to an integer in order to get to work. And here you can see me static casting the set for the voter status because it uses a call to a method within the class in order to generate what the current voter status for that voter is. One thing that I should note is, and this is common when you start getting into the more advanced inheritance, but I actually have a method in here that allows to force the voter status to be able to force a change. Because normally with the public void for the set voter status, you don't get to put anything into it. You just tell it to ping the random generator inside of it and attempt to generate a new one. With the force voter status in here, it actually allows you to force in a new status into the class itself instead of using the random generator. And then I have my constructor right here, which is set first, set last, set voter status, which calls the generation inside of the class itself. And then we have the destructor, which is just going to blank first name and try to blank first name, try to blank last name. and then the catch would be the voter status is changed to dead. Um, Here's just the private method inside of the class that generates the first name. Here's the private method inside of the class that generates the last name. They're effectively identical for pretty much obvious reasons. Go ahead and roll is an integer that is going to actually return an integer. And what that will do is it just goes ahead and generates the rolls. You can see it actually implemented up here in the generate last name. And all that does is it makes a roll in order to decide what the return will be. Then it chooses the return from the list of enums. What I have right here is a static cast of turning the integer into the string, or in this instance, into the season. So it's static casting it into being the, or not season. Season's the example that Microsoft Docs uses. Ah, okay. It actually sends it out to the enumeration list for last names, and that's how it assigns the last name. So yeah, that's pretty much it for that. Then we have three different types of classes that inherit from the person class. We have Democrat, we have Republican, we have Independent. And each of these has their own individual internal flavor text. But up here you can actually see them adopting because they have an instance of person within themselves, rather than modifying or supersuming it or starting off with Democrat or Republican or anything else. The Democrat will actually pull an instance of this person into itself and then register its own internal records off of the basis of what it receives from the person class that it's passed. And you can see this where I use the various gets in order to pull the information into the Democrat class. As you can see, the Democrat class itself doesn't actually have any of its own unique variables, but the main reason that I did this, and I will show it late in a little bit, is because it allows me to give it a unique namespace and class structure, which lets me make use of unique lists for it. So rather than having just like Democrat, Republican, whatever else, just be another enumeration variable within the class, I actually made Republican, Democrat, Independent its own class so that when I'm running through a list, I can do unique lists, which only will trigger on those types. So, moving down here, we see that they are, in effect, completely identical in what they do. The code structure inside of it is literally same, identical. I don't use destructors. There's no real apparent cause for them, since this is only a one-time run through. So for this one, I initialize it so all my various methods can see it on the form, and all the various functions that need to be done with it can see it. I reinitialize it right here, telling it to do a new construction as it's declared. So these folks x equals new person, new constructor. And it runs through this stuff so fast that they literally just end up with the same, almost the same identical information for everything. And this is just, it sets up a new list of people, tells me congratulations, you've generated it. The unique thing that I do, and this comes from my background in developing user applications for septuagenarians and octogenarians, this is what you saw that was making the buttons gray out after I clicked them. The reset button just resets the form back to its original spot so that you can run through the button push cycles yet again. With this, it tried to register. This just runs through and it tries to change the voter status for everything else. And when it does these folks is the person class. When it does the set voter status, it's just trying to get people to register or trying to force them to re-register. You just registered a dead person to vote. Have you no morals? So this one would basically trigger because this voter determines which part of this if-else statement it runs through. And when we get down to here, if originally this voter was supposed to be set to dead and it manages to change it so it can vote, it will go ahead and throw, you just registered a dead person to vote. Have you no morals? It's kind of funny. But down here we have message box.show. We started with blah voters. We tried to get as many more voters as we could. We only got J more voters. So that just attempts to help people get from point A to point B with the voter registration to reflect that people trying to update the ballots or update the voter registration before an election. And yeah, that's pretty much just it. And then down here we see the same kind of method where it sets the current try to register button to being disabled, so you can't click it again. And then it sets the button to cast ballots to enabled since you just went through the registration. And then when you click the cast ballots, I did this in sequence. So this is from my time of having spent doing procedural programming. This is just like a nicety point because since this is a procedural operation, I put the general steps that the methods go through in order because it also makes it much, much easier to troubleshoot. Even though I absolutely disdain and refuse to use go-to statements. So, down here we have private void button cast ballots click. I just use like the prefixes in order to be able to know what form feature I'm dealing with when I type it in. The interesting thing is, as you had seen previously up here, I was using a very finite pre-designated array right here. Persons, these folks, new persons, in order to define it, but then I turn around here and I use lists, and this is where the unique namespace of the classes Democrat, Republican, Independent is actually put into use because it allows me to break the voters up into their various parties, whether those are decided or not decided. And then I have the role generator here. So this will actually break apart the array and cross-assign the people who end up in that party into a new instance of that class and add that to a list. This is one of those places where a list becomes very valuable because when you don't know how many people are going to be specifically in a given group because it hasn't been determined yet, a list is very useful for this because you can scale it up as much as you need to. Then down here, you see that I use the for each. For each is awesome, and for each and lists are super awesome because it allows me to just run through all of it in a very, very rapid pace in order to register all the various votes and to produce the vote log that you end up seeing. And as you can see here, it does all the Democrat votes, it does all the Republican votes, then it makes the independents decide which party they're going to be on. I just used very simple Boolean statements in order to do it equal 1, or if not else, then the Republican, and it just runs through it. And this is just more flavor text with the Republican Party claims the Democrats cheated to win the election. The Republicans have evidence that X of the voters weren't legally allowed to vote. So it's really just flavor text and everything else for the voting season here. My final will actually be an obituary generator for Frostpunk because why not? And a lot of what I've done here with the loading up the strings and everything else is what I'm going to end up doing for Frostpunk. But the main unique thing that I'm going to be using there is that I'm going to be doing a running obituary, which means that instead of doing one of these, I am going to be appending the information to the end of a text file every time a new obituary is generated to chronologically keep track of the people who joined and when they died. Just because it's kind of cool. And Frostpunk doesn't really seem to keep track of it itself. Well, anyways, that's pretty much my presentation. Reset things is both here and here, and all that does is it switches the button states back to having the generate people list at the top. So right after this, I am going to post this video to YouTube, post the stand up, and that's pretty much it. Thank you for watching.